surface area of prisms. There's two prisms, well, it's three actually, that have a really obvious, easy surface area formula. Remember that the surface area is the area of the net of the shape. That is, if you took this, let me zoom out, really dodgy little cylinder that I've made, the surface area would be, if I undid that and just looked at the flat shapes, what would be the area of that? And I'll come back to my cylinder later. Sorry about the manual zoom. So the surface area of a cube is just, look, there's a square and there's 6 faces and they're all identical. So the surface area formula for a cube, if the side, actually you usually prefer this to be L so you don't get it mixed up with 5. This is length squared times 6. Or if you'd prefer, of course, you can write 6 length squared. If you let this be x, you could write it as 6x squared. It's just there's 6 copies of the length squared, that little square. So this formula is nice and easy. The rectangular prism has a really easy formula as well. There's 2 copies of the front and back there. There's 2 copies of the 2 sides, and there's 2 copies top and bottom. And you can see that each of the dimensions gets multiplied together. Length times width here for the bottom, and there's 2 of those. Height times width for the side, and there's 2 of those. And length times height for the front, and there's 2 of those. So we multiply each pair that we could get, add them all up, and times by 2. 2 times length times width, plus length times height, plus height times width. And it really doesn't matter which one is which, but this is our formula for the surface area. I have no idea what happened there. Surface area of a rectangular prism. This is our formula for the surface area of a cube. So very quickly, with a rectangular prism for the surface area, we write our formula. Two times, we multiply each pair. 2 times 3 plus 2 times 10 plus 10 times 3. That will be 2 times 6 plus 20 plus 30. So 2 times 56 is 112 meters, and we're squared because it's just the surface area of, if we folded that all out, what shape, what would be the area of that shape. So those 2 are pretty easy formulas. Now actually, I'd like to teach you a different sort of formula that works for all other prisms, and it does take a moment of explaining. So bear with me, I'll use a cylinder as an example, and we'll zoom out a bit. So you saw this cylinder. It's got height, I'll zoom out even more, height of the cylinder, it's got a circle at either end, there's its radius, and the surface area of this would be, if I carefully took it apart, because I didn't sticky tape it very carefully, and folded it out, sorry, and tried not to tear it in the meantime. There we go. I've got 2 circles and a rectangle that joins them up. Now every prism has 2 identical faces, one at either end, and it's joined, that those 2 faces are joined by a rectangle or series of rectangles that wrap around that shape, like that. So every formula that we're going to use for surface area actually comes down to, we need 2 copies of that face that's the same at either end, the cross section that we call it, and we need the rectangle that will go all the way around it. Having just torn my rectangle here, annoying. The height of the rectangle is quite obviously the height of the prism, the distance between the two faces. But if you look at this width of the rectangle, it has to go exactly around the shape that is the name of our prism. So this is a cylinder, of course, a circular prism. This rectangle has to wrap exactly around that circle. And the distance around the circle is its perimeter, or its circumference for a circle. So the perimeter of that end pair of shapes, just one of them, is equal to the width of this rectangle that we need to find. Now what that means is every one of these formulas comes down to I need 2 copies of this area, and I need the height of the prism times the perimeter of this end shape, and that will be the rectangle that I need. So, zooming back in, the way we write that is the surface area is 2 times the area, and remember that's the area of that cross-sectional face, plus the perimeter of that shape times the height of the prism. So we'll add a couple of notes in here. Area of cross-section. This is the perimeter of the cross-sectional shape. And this is the height of the prism, the distance between those 2 identical faces. Now you can learn the slightly more exact formula for a cylinder, but I just want to show you how it works. If surface area is 2 times the area plus the perimeter times the height, then the area formula for a circle is pi r squared, so this will be 2 pi r squared, plus the perimeter of a circle is 2 pi r. That's the perimeter of a circle, and then I need to multiply it by the height. So you can actually just use this formula for the surface area of a cylinder, but it comes from that formula. You can start with this for a cylinder. So very quickly as an example for this one, the surface area is 2 times pi times the radius squared plus 2 times pi times the radius times the height. And you would just type all that in. 2 pi times 2 squared is 4 plus 2 pi times 12, and that's 100.5, and we're in centimeters squared. Now do just remember when you're using this formula for a cylinder, sometimes they'll ask you for an open cylinder. That is, it doesn't have a top, it's only got a bottom. In that case, you don't need 2 times the area, you would just need 1 times the area, because there's only one circle. And sometimes they'd ask for a totally open cylinder like a toilet roll, where there's nothing on either end, and then you just use this. So it is useful to be able to break up this into the curved surface, and that is 2 circles. Now the triangular prism is usually one of the trickier ones, but the formula, surface area equals 2 times the area plus the perimeter times the height, this will work for any prism. I should have given you the height of this triangle to find this, I'm sorry, so I'm just going to make it up, and it's going to be 10 meters. Sorry about that, this question should have had that height. If you didn't have it, and I'm lying here, it's probably not 10, I'm just making it up. If it didn't have it, you would use either Heron's formula to get the area, or Pythagoras to get that height, and then you'd have it. But I'm just going to pretend it's 10. Now, 2 times the area means 2 lots of the area of a triangle. 2 times half times base times height. That's the area of a triangle, and I want 2 of them. Plus the perimeter of the triangle, 16 plus 16 is 32. That's 50. Sorry about the siren out there. Times the height of the prism. That's 20 there. Because that perimeter, when you draw that net, if you choose to, looking down on this shape and folding it out, this is 20 here. But if we make this 3 rectangles into one big rectangle, 20 times all this distance, then that distance all the way along there is the perimeter of that triangle, because it has to wrap around it. And so this finds the whole thing of all those wrapped around rectangles without us having to find it separately. So very quickly, 2 times a half cancels out, so I've got 10 times 18 plus 50 times 20, that's going to be 1,000. So 180 plus 1,000 is 1,180, and we're in meters squared. So this formula here is really powerful when you've got prisms, because it means you don't have to keep track of all these different little rectangles, because 2 of those are the same size but the 3rd one isn't, and you get tripped up on that. Whereas if you use this for any prism, except those ones where there's a nice easy one. So cylinder, use this. Rectangular prism, use this. Cube, use this one. Any other prism for its surface area, this is the formula you want.